Welcome to PrairieLand Partners explanation of downforce and margin. This is for John Deere planters, and we're dealing with spring 2020 planting season. We hope this video helps you understand how downforce and margin relate to each other. Now, the downforce and margin relate to each other on three different styles of software: SeedStar XP, SeedStar 3, and SeedStar 4. Now, each screen is unique to their design, but the point is all of the margin systems and downforce systems act the same, and so we're going to have one video covering all three. Now, why are we talking about this? Well, that's because margin matters. Ideal margin results in uniform plant emergence. According to industry studies, margin, which is not ideal, can result in a 10 to 18 bushel to the acre yield loss based on a 200 bushel average corn yield field. Now, if you just put a price of $3.50 on each bushel, that's $35 to $63 per acre of loss by something that is usually adjustable from the cab and after we understand the system. And that's the purpose of this video. Now, what does uneven emergence look like? This is a good example. What happened here is the plants on the row closest to us, the three in the middle, those plants probably didn't get to the wet soil in the bottom of the trench, whereas the ones to their right and left did. And so what happens is that throughout their growing life, the short plants end up on the short end of the stick for sunlight, nutrients, and all growing factors. So what affects emergence? Well, planting depth, of course, does that. But usually each row has a similar and identical planting depth. So that wasn't it. It's probably the seed environment that affected those three plants. So what we need is corn seeds ability to wick moisture from the soil into the corn seed and start its sprouting process, as you see here from left to right on the top picture. So what we need is good seed to soil contact, and that comes from ideal margin, and of course, soil moisture. So we need to go to moisture. My dad always said plant to moisture. So what we need to do is make sure we adjust our planter to where we can get that. Now, we need good seed to soil contact. In fact, if we don't have it, we may get an air pocket around that seed, which causes poor transference of that moisture. Or if we didn't get residue out of the way and hairpinned it with the double disc openers into the seed trench, that too slows emergence. Now, of course, soil temperature and crusting at the soil surface are factors we need to take into account. But as far as emergence and what we can adjust from the cab, those two have to be dealt with in other ways. Now, residue is our friend, but residue needs to get out of our way so we can plant. So what you see here is the three plants in the red rectangle came up late because they got planted in residue, and they probably had to wait for the next rainstorm for them to get germinated. So they're quite behind and may never catch up. So what are the planter settings that will affect even emergence? Well, number one, we need row cleaners and coulters set correctly so that we get that residue out of the way so we can be planting in a clear dirt only trench. Because what happens if we don't get that residue out of the way, we hairpin it, we bury it with the seed, and that lessens the amount of moisture the seed can receive. One of the ways we can control that is with gauge wheel loading and or what we call margin. The seed depth, if you don't have adequate margin, your depth of the seed is going to be wrong, and that's not good. You then need to have good seed to soil contact. You need to have the seed in the moist part of the trench, and you do that with gauge wheel loading, and that comes from Downforce. Now, please remember that closing wheels are a upforce device. And even though they're part of our trench closing process, they actually are fighting against our margin. So the goal of this whole process is good seed to soil contact at a consistent depth. And that to accomplish that, you need to have ideal margin. Now, when you have ideal margin, what you're able to do is see a seed trench like you see in this engineering drawing, or let's go to a real one here. There is a ideally set up with downforce and being correct and margin being correct seed trench. That seed trench has to stay intact between the double disc openers and the closing wheels, and the seed needs to be in the bottom of that trench. So the trench has to stay intact that length of time. So we don't want loose soil falling in around those little kernels. We want those little kernels in the bottom of the trench where it's always going to be the most moist. Now, what happens if you don't have enough downforce, which results in low margin, is you have inconsistent seed depth. The trench falls in and dry soil is near the seed. And then when we close it, we have dry soil around the kernels and they don't start germinating. So that is the problem with the trench collapsing is we have dry soil around the kernel. What that also looks like after the next rainstorm is the two plants on the left-hand side of the picture. Most likely what happened is we did not have enough downforce or adequate margin, and those plants got dry dirt around them, and they had to wait for the next rainstorm before they germinated. Versus the plant on our right, it got into the wet soil and got growing, what, four leaf faces ahead. Of course, it's possible to have too much downforce and therefore too much margin. This is what that looks like in the left-hand picture. You've got compacted trench sidewalls. You have gauge wheels that have to be, the dirt has to be peeled away from them. And what happens is in too much downforce and margin situation is the roots actually kind of get compacted. And so you have poor root formation because this soil is so dense, the young roots don't have much of a chance to get started. So let's see how this all functions. We're going to talk about the forces acting on a row unit. We're going to break them into three simple characteristics: forces pushing downward, forces pushing upward, and the difference between those two is what we're going to call margin. So let's summarize these. Down forces are weight in the seed box. So that's a 3-bushel hopper shown in this video. That's going to be a lot of weight until the seed is nearly gone. The row unit frame is a constant 100 pounds, and the downforce device shown on this particular unit is a pneumatic downforce device. Those are the three things that are pushing downward for us. That's good. Up forces are what we have to counteract. So the soil's resistance to row cleaners, coulters, the double disc openers, and the closing wheels, those are the things we're trying to push downward with more downforce than the up force. And that's what we call margin, is weight on the gauge wheels. And that's why I put the red line there underneath the gauge wheel, showing that that is the weight that's left over between down forces minus up forces. So if you like math, the equation is that down forces have to be bigger, that when you take up forces away from them, we have weight left over, and that's called margin. So there's our successful planting formula right there.